Good morning, one and all. So today our topic is spectroscopic techniques and applications. Spectro means radiation, scopy means measuring. Measurement of radiation is known as spectroscopy. Coming to the definition, it is a branch of science which deals with the study of interaction of electromagnetic radiation with the matter. Once the electromagnetic radiation is interacting with the object, then there is a possibility of different types of phenomena such as absorption, transmittance, and reflectance. Whatever the electromagnetic radiation is falling on the object, it may absorb. So depending upon the what type of radiation is falling on the object, that type of spectroscopy we are going to study. So here we are taking the electromagnetic radiation that is falling on the object. So first we will see what is the electromagnetic radiation. It is also known as a EMR, that means electromagnetic spectrum. This electromagnetic spectrum is having different types of radiations. It is starting with the gamma rays and ending with the radio rays. Gamma rays are having the highest energy, whereas the radio waves are having the lowest energy. Gamma rays are very, very strong. After that, X-rays, and then comes ultraviolet radiation, and then visible radiation, and then infrared radiation, and microwave radiation. Next comes the radio waves. Electromagnetic spectrum is a complete spectrum of all forms of light. An electromagnetic wave consists of electric and magnetic fields which vibrate, thus makes waves, just like vibrations. Coming to the definitions which are involved in the spectroscopy. So first comes the transmittance. Transmittance, it is the ratio of intensity of light transmitted by a sample I to the intensity of incident light on the sample I naught, whereas it will be represented with T is equal to I by I naught, where I is transmitted light, where I naught is incident light. Percentage of transmittance is equal to I by I naught into 100. So next, absorbance A. Absorbance of a solution is defined as the log to the base 10 of the reciprocal of transmittance. If you write it in the equation form, A is equal to log 10 1 by T. It can also be written as minus log 10 T. So if you substitute T value here, transmittance value here, that is I by I naught, then you will get log 10 I naught by I. So next comes the definition, absorptivity. It is the characteristic of a particular sample for a given wavelength, and it is defined as a ratio of absorbance to the product of concentration and length of the optical path. So that is represented with the letter A. A is equal to capital A divided by B into C, whereas capital A is the absorbance, B is the path length, C is the concentration. So next comes the definition, molar absorptivity. It is represented with a letter epsilon. It is the absorptivity expressed in units of liters per mole centimeter. The concentration is moles per liter and cell length in centimeter. So similarly, whatever the absorptivity is there, here in that wherever the concentration is there we will take in terms of moles, whereas in the absorptivity we will take the concentration grams per liter. So epsilon is equal to A by M divided by B into C. Epsilon is known as the molar absorptivity constant. Thank you, everyone.